very much digitalized. But second from the bottom, only second to agriculture and hunting, is construction. And given that we actually do work in a high-tech industry, traditional, yes, but high-tech also, that's really quite shocking to me. So the government has set up the industrial strategy around supporting the construction industry, so the construction sector deal. This is £170 million that's been given to the construction sector for various projects to help us reinvent the sector, support the sector for the 21st century. It's about recognizing for us that by increasing the adoption and use of digital and off-site manufacturing technologies and techniques, we can improve productivity and we can improve life of people within the UK. So this is what we call a digital built Britain. We think when you're building anything, it could be a building, it could be a piece of infrastructure, we think there are four main stages. We talk about the design of that building. And at that stage, you need to think about what data do you need? How are you going to share that data? How are you going to make sure that that data is secure by default? How are you going to make sure that you're thinking about who needs to see the data and how they need to see the data? We need to think also about what about our smart contracts? How to procure, taking into account the data is a really important part of that jigsaw. And we think that this will give us opportunities for new careers and new businesses within the built environment. You've then got to build your asset, your building, your piece of infrastructure. And we really need to look at digital construction techniques. How do we manage the information? What manufacturing technologies do we need in that build stage? What about kit of parts? What about off-site construction? And then how does digital bring that together? How do we make sure that we're sharing that data securely and resiliently so that contractors, the clients, they can all talk, they can all share appropriate data? Now, in the UK, we're pretty good at doing that piece, the design and build piece. The piece that we're starting to get super good at, and there's more work to be done, is how do we operate our assets? When we finish the building, we used to historically hand over a big chunk of paper and the keys and say, there you go. How do we do that with the data? How do we do that in a really useful way so that people can use the information they've got from building their asset and from running the asset to make it run better, to make sure that you can have scheduled maintenance, to make sure that people can use those buildings in a way that's comfortable, useful, and productive to them. And then when we've got that highly efficient building or infrastructure piece operating really well, how do we link it with other assets and integrate it into a system of systems, a suite of buildings, a suite of infrastructures, and make sure that we are sharing information, data between those buildings to make sure that we operate as a system to create even better results. At CDBB, we're part of the Construction Innovation Hub. Now, that's an alliance between us at the University of Cambridge, the Manufacturing Technology Centre up at Coventry, and the Building Research Establishment at Watford. It's part of the construction sector deal under the ISCF that I was talking about before. Within the Construction Innovation Hub, we talk about four things. We talk about value, and I'm not just talking about money, I'm talking about the environmental value, the social value of our buildings. We're talking about using manufacturing techniques in construction. We're talking about assurance. How do you check that everything's been done correctly and it continues to be done correctly? And we at CDBB, we lead the digital stream. So we're talking about how do you use digital to build things better? How do you use digital to build better things? We've created a large number of working groups because we know, sitting at Cambridge, working with some brilliant people, we need to work with even more brilliant people. We're about a collaborative program. We're about coordination and not control. So we have a public sector ISO transition working group. So those of you who are sad like me will know about the ISO 19650 that led on from the PAS 1192, all around data and information management within building. Some people will say they're standards for BIM. I think it's much further than that. It's not BIM, it's information management as a whole. So this group looks at how do we embed those standards into government departments. We have a Home Nations working group to make sure that all 4 home nations are aligned in their thinking about effective information management so that we can share ideas and learn from each other. We have a local authority BIM working group, which does what it says on the tin. It works with local authorities to make sure that they are picking up BIM techniques and BIM ideas and using them. A buildings clients group, which helps accelerate digital transformation within the buildings industry as opposed to infrastructure. One around interoperability of BIM, So are we looking at IFCs? Are we looking at Uniclass? What are we using? We have a digital framework task group, which I will come back to later, and a digital twin hub. Both of those are part of the National Digital Twin Programme. And that's what I'm going to speak to you about now. So the National Digital Twin Programme is about linking digital twins. It's about having lots of digital twins that will speak to each other so that we can run our infrastructure better. So how did it get set up? In 2017, NIC set up Data for the Public Good, and it recommended a national digital twin, which is an ecosystem of connected digital twins. It recommended an information management framework, which is a way for us to share data, different types of data, securely and resiliently. And it recommended a digital framework task group, which coordinates and aligns the many players within this area. It allows us to enable, to deliver, and align to create this national digital twin. The basis of a national digital twin, a connectable digital twin. So you have your physical asset here on the left, and you have a digital representation on the right. And for us, a digital twin is about that physical asset sharing data with the virtual. But here's a really important thing for me. Then it's about the virtual giving interventions back to the physical. It's that intervention link that for us makes it a digital twin. You can also have information flowing into that digital twin and out from that digital twin from other digital twins, so connectable digital twins. Imagine you have your transport system here in red. It would be great if we could connect that up with the energy system and the water system, and this is what a national digital twin will do on a much bigger scale. So essentially, you have a cyber-physical system. You have your physical system, the world in which we live. For us, we define that as the built environment. That's the remit that we sit in. But of course, it goes out to finance systems, to the natural environment, to the social environment. And by collecting data, sending it to the cyber system, if you wish, modeling and sending interventions back, you then have a connected ecosystem of digital twins. The benefits of having this national digital twin are bluntly better outcomes to the public per whole life pound. So we're not just talking about the CapEx at the beginning of a project, we're talking about how do you run the whole life of your asset and how does that affect the people, the businesses, the economies that are attached to that asset. So clear economic benefits, but there will be new businesses. This is a new way of thinking about systems, a new way of thinking about our infrastructure. New markets, new services, new business models will arise. We're not going to make our net zero targets unless we use our data better. And the National Digital Twin is exactly one of those. It's about creating less disruption and less waste. It's about being able to do the calculations properly in a holistic sense so that we really know whether this change on this building has a positive impact on carbon, on energy, or whether in the holistic sense, actually it's neutral or negative. So the National Digital Twin has a number of benefits that will come out of it. It's not something that you're going to see turn up next month, but there will be more connected digital twins and allow us to progress towards the National Digital Twin. I wanted to talk a little today. We're all in a very unusual situation. The COVID-19 pandemic has made us think about how do we work, how do we live, how do we use the buildings and infrastructure in our environment. So this recovery, resilience and transformation in the construction sector is very much at the forefront of our minds at the minute. And we at CDBB have three main ways where we think we can support that. Let's look at digital approaches to asset delivery. As we reboot the construction industry, as we start again, let's think about how we can use digital to boost productivity and jobs by reducing cost, time, and lifetime carbon emissions. This will allow us to think about new ways of working, but it will allow us to work smarter. For a moment, think about how our lives in the last 3 months would be different if we hadn't had the internet, if we hadn't had Zoom calls like this. Exactly the same thing applies to construction, to buildings, to asset management. With digital, we can work much smarter. If we have better information, we should have better outcomes. So by using our information from our buildings, from our infrastructure, from our natural environment better, to allow us to make better decisions, it will allow us to be much more resilient when the next crisis strikes. And I say when because it won't be C-19 next time, but it could be climate change, it could be a volcanic eruption, it could be another pandemic, we don't know. But through better use of data, it will allow us to quickly run scenarios to work out what is the best outcome, what is the best route to take, making these value-based decisions. Part of this for us is the UK BIM framework, which is the UK's guidance around the ISO 19650, but also around the Gemini principles, which are for us the conscience about how you use your data, how you share your data. And we're also very keen to provide tools, guidance, support on better information management, because this has to become business as usual if we're going to be resilient. We're also very aware that we have to work collaboratively now. I think this time for the last 3 or 4 months has shown us that. For a recovery effort, we need to make sure that no one is left behind. We are working to co-deliver with the Construction Innovation Hub and to champion the Gemini principles, the conscience of how do we share data. Please come and join us. Please join a CDBB working group. Collaborate with the Digital Twin Hub, which is a community of digital twin owners and people interested in making real progress in digital twins. Or connect with us through our digital channels, or just read the website, find out what we're doing, and come and ask questions. We're very much, as I said, about collaboration, about coordination. So we really do want to hear from you. Thank you very much.
Thank you, Alexandra. Fascinating, brave new world springs to mind. Okay, right. So just a reminder to our attendees, please do raise your Q&A or questions in the Q&A tab. So let me hand over now to James and Philip to share their screen and give us their presentation.
Okay, well, thank you very much. My name is James Pickard of Cartwright Pickard Architects. We're a 50-strong architecture practice with our head office in London, but offices in Manchester and Leeds. We pride ourselves in always carrying out research-led projects within the practice, and we very much focused on research-led design. I think this opening slide, excuse me, really distills what our the KTP research project that we're going to present was all about. We got Innovate UK funding, but we also got support from the wider industry. So we've got about 15 to 20 minutes really to explain the key aspects of a 28-month government-funded research project, which has resulted in the creation of a new prototype software platform developed by Cartwright Pickard, which for now the working title is 7D BIM. So our research was financially backed by a group of blue chip industry partners. Do you want to go back one slide, Philip, to the previous one if you are able to? That's it. Yeah. So our research was backed by this group of industry blue chip partners, which included members from the insurance industry, construction, manufacturing, engineering, and property development. The technical input, as well as financial input from these partners, was incredibly valuable in helping us progress. So next slide. Since its inception 24 years ago, Cartwright Pickard has been driven by determination to challenge the status quo and to improve the way we work and project outcomes through research-led design. This journey started with our very first built project at Murray Grove, which was the UK's first fully modular apartment building, which was designed and manufactured for the Peabody Trust and completed over 20 years ago. Just to give you an indication of how slow the construction industry is to change and how slow it is to adopt modern methods, modular construction is only recently now being taken seriously and more widely adopted, particularly in the build-to-rent sector, which is a pretty new sector for the UK. So why have we invested 2.5 years researching the integration of whole life costs and carbon with BIM. So I think this slide speaks for itself. The government's targets of 33% reduction in capital cost of buildings, a similar reduction in whole life costs, 50% reduction in greenhouse gases and project timescales, and a net zero economy by 2050. And all of these previous government funded reports that we've seen that, to be honest, have had fairly small effect on the construction industry, which is a bit like an oil tanker. It's very, very slow to change. And as we've already seen from the previous speaker's slides, that McKinsey slide that shows that the adoption of digital technology in the construction industry is woefully low, right at the bottom of the heap, just above hunting and agriculture. So we've got a huge amount, a mountain to climb and a lot to do. So this next slide, I think, says it all. The difference in productivity between manufacturing, which is the grey line at the top, and construction, which is the red line at the bottom, that difference, as you can see, is absolutely huge. A sort of roughly a 60% difference in productivity. The UK construction industry is notoriously expensive. I think I've seen international figures showing that the UK is pretty much the most expensive country in the world to build any building. London and New York and Tokyo obviously vying as the leading cities, but Britain as a country we are very expensive. We don't build efficiently enough. So, you know, these government targets that we've had have been set to address historical inefficiencies of fragmentation and poor productivity of the UK construction sector. We believe that BIM can improve productivity dramatically, and will also creates the need to rethink our current working processes and implement more highly integrated project design and delivery processes. So we go to the next slide then. So this is quite an eye-opener if you're an architect. Remember, we're only humble architects. We're not scientists or people that are that specialised. But when you realise that your industry, the construction industry, accounts for nearly 40% of all UK carbon emissions, but also about the same percentage of all global carbon emissions. That's the construction, manufacturing of building, but also the running of buildings. This is identified by the United Nations, and our industry could have a huge impact. It's the largest single sector in the world, and therefore we can have the biggest impact for reducing carbon emissions. So there's a huge opportunity. So this slide is really trying to illustrate that we all know on the left you've got the average carbon footprint of a UK citizen at around 10 tonnes per year. So we thought, well, if you divide the total annual carbon emissions from UK construction industry by the number of registered UK architects, just out of interest, you come up with a figure of 1,365 tonnes. So by anybody's standards, architects have a huge gift, an enormous social responsibility to drive down the carbon footprint of their buildings. We can have far more impact than the vast majority of people in society who, even if they cycled everywhere, became vegans or didn't go on holidays in aircraft, flying, using aircraft, could probably only just about halve their carbon footprint, which would be a tiny smidgen compared to what architects could do. So we think there's a huge opportunity here for us to grab. Next slide. So this again is quite an eye-opener, this slide, for my profession. We're all focused in construction on CapEx. We're all trying to drive down to the lowest construction cost, and nobody really thinks, not until fairly recently, but still it's not particularly wide in the industry, people are not focusing on the overall life of the building and what it costs. So we've researched and found out that actually 80% of the cost of a project is during the 30 years of operating that building. Now, if you just take the public sector, which is approximately 50% of all construction, schools, hospitals, affordable housing, you imagine the impact that if we focused more on those operational costs and operational carbon, think of the huge impact that we could have. We've tried to show here the different RIBA stages. And what we have discovered is that the first 20% of the design process is where we have the biggest impact. So I think that's the next slide, Philip, if you want to go to that one. So this is a graph from the Treasury, which supports our own research that the opportunity to reduce embodied carbon is far greater at the early stages of a project, and the same principles apply to cost. So our research estimates that 80% of the potential for reducing whole life carbon costs and costs is during this concept stage, which, if you like, between starting a project with a brief and working towards a planning application. Now, it's that stage where architects have the biggest influence. Contractors don't get involved in projects until after they've got planning approval, and sometimes not even for significantly a longer period after that. So contractors are left with very little wriggle room, very little space to actually make savings in whole life cost and whole life carbon. It's very much the design consultants who have the gift of the opportunity, the golden opportunity to lead the industry. And I believe architects have been marginalized for 30 or 40 years, and it's now an opportunity for us to sort of lead from the front for a change. Next slide. Yeah. So our aim is to integrate whole life costs and carbon considerations from the earliest stages of concept design and throughout the design development. Firstly, we've had to standardize information delivery processes and develop a protocol for better information management using BIM. We believe BIM is going to be at the heart of the revolution or evolution that's got to take place in the use of digital technology in the design of the built environment. We've had to automate repetitive tasks and processes of integrating whole life costs and carbon through the development of prototype software. And we've developed an application to prove our concept. We're actually at a stage now where we're talking to funders to take this prototype application and turn it into a marketable piece of software that will benefit the industry more widely. Next slide. So how have we defined 7D? We're all aware of the 3D capabilities of BIM. However, the true potential of BIM is in the data attached or linked to the 3D model. This information can be about time, capital cost, environmental performance, durability of components, as well as operational maintenance costs and carbon. All of these considerations together encompass the whole life, holistic scope of whole life cost and carbon. We've carried out one of the first major research projects in the world looking into the integration of BIM and whole life cost and carbon. We have yet to find anyone else doing anything like the 7D BIM development that we've done. We have not found one. So our dream from the beginning has been to create a valuable decision support tool to help designers make better choices. I'm now going to hand over to Philip Lammers, our head of BIM, and he is going to give you a very high-level 10-minute snapshot of how our prototype software works. Over to you, Philip.
Thank you, James. So the basis for our prototype is a conceptual framework, which is arranged around the three main pillars of processes, technologies, and whole life cost methodologies. This derives from a thorough review of literature, meetings and discussions with consultants, FF teams, software providers, and academics. Following on from specifying the scope of information exchange, the what, it is also important to make the how explicit. Provision and use of a file-based common data environment is an essential part of stage 2 BIM compliance already, but the estimation of whole life cost requires a much more sophisticated data structure in the form of an object-based information storage. Aside from this aforementioned adoption of an object-based information model, our prototype is based on a number of other technologies and processes that have emerged or came to maturity in recent years. Some of them are unique to our project, like a dynamic cost database that was developed and has collected data over a 40-year period. The result is a design decision support tool, allowing us to make informed decisions at key milestones during the design development process. The decision-making process, including options explored, is thereby documented and summarized for future reference throughout the build asset's life cycle. Our prototype consists currently of 6 distinct modules. Each of these is a proof of concept in its own right, demonstrating different aspects of functionality. At the core is the web app. This is where the actual calculation happens and project information is stored. We decided against the desktop app for better accessibility and a quicker deployment across large project teams. There are links to existing cost databases. Currently, we support 3 different sources, although in the long term, we hope to build on live data that is fed back through a standardized process. Plugins allow us to pull in model information into the web app and also present results back to the designer, supporting them during the decision-making process. While we have dashboards within the web app for easy dissemination of results, we will allow stakeholders to integrate the output within their own business intelligence systems, such as Power BI. To allow integration with an ecosystem of related applications, we will provide an API using Swagger. Simplicity and a low entry level are important aspects for our team, allowing the user to engage without complex barriers and making it viable even for early design stages. We can start with something like a volumetric massing model, just an example here created in Revit. To calculate a high-level whole-life cost estimation based on a simple unit mix. We're obviously aware of other design tools, aside from Revit, sometimes even more sophisticated generative design tools. We intend to integrate with these ones via native plugins through the most common authoring tools, but we will also support other tools via IFC. However, we're keen to demonstrate here that it does not need to be complex. Each variation or calculation is stored as an option set in the project database of the 7D tool, from where it can be compared against others' previous considerations. Critical for reliable functioning is a robust and efficient mapping between the model elements and cost items in the database. While there are some means to assist users through auto-detection of missing or wrong element mapping, there will be also a straightforward tool for visual inspection, allowing the user to identify, isolate, and correct issues directly within the tool's interface. Coming now to a more detailed example. However, it's not always that we want to remodel elements to test alternatives. Taking this stage 3 or stage 4 component model as a basis, we can see the cost for all aluminium windows as present in the model and calculated by the tool is around £3.3 million and a carbon impact of 868 tons, both over a 50-year period. Instead of remodeling or changing the element parameters in the model itself, we have the possibility to override these as an option directly through the 7D tools interface. Without changing the elements of the actual model, we are now giving the what-if feedback or override option. In this example, we can now see that 425 windows, if made from timber, would cost us £4.1 million and emit an equivalent of 393 tons of CO2. Notwithstanding other aspects, of course, spending £750,000 more over 50 years appears to save 450 tons of carbon. That would equate to an individual reduction of 45% alone. Just a warning, the next slide contains an animation. It's intended for a live presentation and sometimes it stutters a little bit on Zoom. So while the plugin, as seen in previous slides, addresses the needs of the designers, the web front end will allow other project stakeholders, such as clients and operators, to engage with the process as well. Data from the plugins is synchronized via the web front end and vice versa. The integrated model viewer is thereby intended to be used to use the actual CDE hosted model subject to the CDEUs, removing the need for separate uploads and making sure that the entire project team is using the same most up-to-date model at any time. While this web front end is also where the project is set up and managed, a 3D model view, the 3D model view and dashboards will give direct access to the various whole life cost options. These dashboards will provide in-depth analytics, helping the user to understand the relationships between components and design options. I'm closing with just 2 examples of calculations undertaken with the prototype. This first one demonstrating once more in detail the economical and ecological impact of different window type materials, their cost broken down by cost categories as well as by the embedded carbon. And a second example where we can see the potential impact the choice of soft flooring can have on the maintenance cost for the asset over a 50-year period, outweighing many of the other components tested in this comparison. At this point, I say thank you, and I'll hand back to James for a closing summary. James, I think you're still muted. Oh.
Thank you, Philip. And obviously that's been you've only seen a very small snapshot of the prototype software that we've developed. In the time we've got, but hopefully that gives you a flavour for what we've been doing. If you go to the next slide, Philip, please. So we just set out what we consider to be some of the wider benefits if we can make 7D BIM a reality and not just our dream. We see this as a golden opportunity for architects and design professionals to lead the industry for once, and to stem a continuous sort of marginalization of the design professions, who I think have been not proactive enough or left out of it for far too long. And now is the time that we can actually have a really good impact and help the changes that are required. So this next slide, I won't dwell on all the RIBA work stages that we all know, but we've just tried to set out some of the key benefits that the 7D BIM software that we're aiming to bring to market work from the very early stages, where we see where the die is being cast is where the big gains can be made. And I did say earlier, we finished 2.5 years of research and developing the prototype software. We now need to raise the funding for another 2 to 3 years to turn this prototype into a marketable piece of software. So anyone in the audience that's interested to talk to us, we'd be very keen. We're already talking to some quite large industry investors and some of the previous sponsors of the research, but we're certainly in a position where we're looking at fundraising now to make this a reality. Thank you very much. I'm sure there'll be some questions.
Super. Thank you very much, Alexandra, James, and Philip. So if I just quickly just put up the names of our speakers again. Right, so over to the Q&A. But before I do so, let me just let me just run through a couple of things. So fantastic talks there. I think we heard about the cyber physical system coming to light. We talked about 7D, the 7th dimension, is potentially carbon and operational expenditure. You heard it here first at CFCI. And there was also some quite sobering thoughts about our lack of productivity in the construction industry and the lack of investment as well. But I think on the positive side, we have people like Alexandra, Philip, and James working on what's going to come next. So if I can start with the Q&A. So please do raise your questions as we talk to the panel and open up to Q&A. Now, let me just start with the first question, I think, and I'll put this question to Gavin and perhaps to our other panelists. But Gavin, 1998 was the Egan report, as we saw in James and Phillips's slide. For 32 years now or so, we've been, as a construction industry, been challenged to become more like a manufacturing industry. What's your view on how that can happen, and actually will it happen, or will we continue crafting projects and buildings on site for many years yet to come, Gavin?
Well, it's an interesting question. I think that there is, before I sort of decide or put forward if you like, an opinion on whether we'll still continue crafting buildings, I think that one of the challenges that I've, that in my own research over years of working in the industry that I've discovered is that we all do sort of tend to start again, and manufacturing industries tend to spend an awful lot of time building prototypes and then creating the final product. And we spend an awful lot of time building individual units that are fully designed from the outset, time and time again. So I think there's quite a difficult sort of interconnect there. So how do you stop building something novel every time you build it? But we also have the situation where we have novel positions in which to build buildings. So each building or each project to build a building has quite often a new team assembled. It has a new client who may not be a full-scale developer who hasn't done it for many times over many years. It's in a different position. It draws together resources from all over the place, and therefore it's a very different industry in that respect. Whether it should be or not, maybe for further discussion. On top of that, I also think there is substantial opportunity to get closer to the manufacturing side of things with the use of off-site manufacturing. And the digital technologies we've just been talking about. I think that is the direction we need to go. It will reduce waste, it will increase quality, it will increase safety. And there was, coming back to projects, if you like, and construction as a whole, I'm more interested in the reasons why we're actually right at the bottom of that list, and sort of garnering opinions about that, because understanding why you're at a position will give you a better understanding of where you need to go. And I'm sure that both James, Philip, and Alexandra will add to the mix. But I think that's what I've described as that issue about everything's new every time you build a project. I think it's had a massive impact on it.
Super, thanks, Gavin. Right, we've got the questions coming in quite thick and fast here, so let's have a quick look through there. There's an interesting question here being raised. Will the CDBB be making any recommendations to address how to avoid the creation of private monopolies controlling the digital systems necessary to deliver on their aspirations? I guess that's an interesting question, perhaps for both Alexandra, James, and Philip, in terms of this software and the resulting intellectual property that comes from it. Will it end up be controlled by the few or the many, and what's your view on that? So perhaps Alexandra, if you want to comment first, and then
yes,
James and Philip. Yeah.
Thank you. Yes, I'd like to. So CDBB is publicly funded, and it is for the public good. So we are tech agnostic. So we work with anybody who has technology, and we want all our outputs to be available to the public at wide. Our aim is positively not to create a single monopoly, or much as it might be nice to be millionaires ourselves, that's not what we're here to do. We're here to create something that works for the nation. The National Digital Twin is a national thing owned by the nation for the nation. There may need to be a group that looks after it, that helps coordinate, but in my view, that again is held on behalf of the nation. So the whole ethos of CDBB is to do this work publicly, to put all the results out into the public domain. Of course, commercial companies will have access to that work, and there will be commercial benefit from it. So our view is that there's a core which has to be owned by everybody and is the center of digital within construction, of a national digital twin. And then there will be opportunities for commercial competition all the way around the outside of that. And part of the government's move towards making more opportunities for firms will be that commercial competition that will happen. So I would stay away from making any recommendations. I'm just one person sitting in Cambridge, but the ethos of CDBB is very much for the public good and to make all the data, all the ideas, all the tools, all the guidances public.
Thank you, Alexandra. James and Philip, is there any plans on commercializing your software, or is it something you're developing just in-house at the moment?
I think the first thing I would say is that as architects, we're only too aware of the cost of license fees for software. It becomes a huge part of our expenditure. And there is also a fairly limited choice in terms of the BIM software platforms that architects and designers have access to. So I think there is an issue with not enough diversity in choice, and which does tend to drive up the cost of software. We basically need funding to take our prototype to the next stage, and if we could get public funding for that, that would be fantastic. And then obviously the end product would be publicly available. We're at that very difficult stage where we've got to find some funding to take it forward, and the private sector looks for a return if it makes a big investment. So we've got to make some choices, but it's all about where does the funding come from. So it's difficult for me to determine until we've actually got the funding to take the software to the next stage. But I'm a firm believer that we won't be the only people doing this. I'm sure there'll be other similar software products sprouting up all over the world, and hopefully causing a bit of a wave and improvements to the way designers make decisions, so we will make better decisions.
Super, thanks, James. One of the questions here is, what is the incentive for private sector building clients to fund the development and, I guess, the maintenance of a digital twin? I guess in some respects, James, you touched on that in your presentation, and that and Alexandra, the feedback loop will lead to operational efficiencies, which I guess is this whole issue about investing money now. You know, what's the Kickstarter to that investment, and sort of linked to that in terms of cost and investment. We've got quite a controversial item here raised about lowest cost criteria in design and construction. Tendering leads to low margins, and does the panel believe that this sort of environment leads to a lack of productivity in our construction industry? I guess that sort of goes outside of the digital build discussion we're having today, but I guess we've not only got to have a digital revolution, we've got to have a revolution in the construction industry in terms of procurement and value to support the digital build initiative. Does anybody want to comment on that?
I'd be happy to make a comment. I think you just have to look at the house building industry. There's still the vast majority of homes built in Britain use 4,000-year-old technology, i.e. the brick. And has life really moved on much in the last 100 years? And the answer is not really. You've got a satellite dish on the side of the house and you've got double glazing, but we still build in a fairly traditional way in this country. And you look at other countries in Europe, much smaller economies than ours, in Scandinavia, Belgium, and they are fantastically more productive because they do a lot more off-site. And I think we've just held ourselves back through lack of innovation. And I think the industry is plagued by short-termism and the short-term profit, and keeping the capital cost as low as possible to maximize the short-term profit seems to be the name of the game. And nobody's had an eye on the long-term implications and the long-term whole life costs, which we all now realize that unless you try and predict it and measure it, we're never going to achieve the government targets. We don't stand a chance. So I think, you know, we've been talking about digital revolution and what the digital technology can do for our industry, but I think we need innovation across the piece to lift ourselves up in from those dreadful productivity levels that the industry achieves. So we get a very poor level of bang for our buck in the UK construction industry for all sorts of reasons. And I think it really starts at the top, which is the way clients, organisations procure buildings, because there's still this tendency to go buy the cheapest capital cost, which means that the main contractors are always on incredibly tight margins. And we've seen what happened to Carillion buying Turnover some of the largest construction companies in the UK make, they're happy if they make 1.5% profit on construction turnover, which is ludicrous. So somehow we need to turn this into a smarter industry that is more profitable, but also delivers far better value, and is less short-termist based. That's my view on it.
If it could I add to that? Just taking on board what you said, James, about the industry and the way that it's quite short-termist. It is quite short-termist, particularly in residential development for sale. Do you think that the market in Europe is generally more mature as far as build to rent and PRS is concerned? And I'd suggest that is probably one of the drivers why their industry is probably ahead of ours in terms of longer term and more innovation in housing, because it has a greater, investors are looking for a long-term fix for something that's not going to cost them substantially more over the period of ownership. Do you think that may have an impact on it, and the bringing forward of more build to rent in the UK will impact that?
I definitely do. So we've spoken to some of the largest build to rent investors and pension funds, and they've said, they can predict rent levels, which generally since the end of the Second World War have increased with inflation, sort of 2 to 3% every year. Rent levels are predictable. It's the whole life costs over 30 to 50 years that are not predictable. And if only as an industry we're able to predict those better, it would mean more certainty for the organisations that are investing in build to rent. I believe the build to rent sector is huge in America. About 30% of all Americans, I believe, live in a build to rent product of some kind, whether a house or an apartment. And in the UK, it's tiny. So there's a huge opportunity in the UK for us to focus on whole life costs and whole life carbon to the benefit of the organisations that are actually commissioning those buildings. Obviously, let's not forget that the public sector, I believe, is roughly half of all construction. So our government, every local authority, every university, hospital and school should have an overriding interest in how much it costs to run their buildings over the life of those buildings, and not just capex. So the issue's got to be addressed.
Thank you, Gavin and James. So we've got quite a few questions about some of the detail of your software here, James and Philip. Now, one of them, for example, is asking about what software you're using in terms of specification, MBS. There's some interesting figures or questions about what data are you using on carbon and cost, what databases you use. Now, I guess that forms a bigger question, is in terms of how are you going to, or how is our industry going to tackle this challenge of reporting these figures? Because at the moment, in some respects, it's a bit of a free-for-all in some of these emerging areas of, in particular, embodied carbon. And it does make me wonder whether there should be a national database that your sort of software would plug into, if that makes sense. So that we're all working from a common thread. I guess the question for Philip and James is, and perhaps Alexander has a view on this as well, but what data are you using for things like cost and carbon? Where does it come from? Is it your own data, or is it a UK government database? Any thoughts on that?
Do you want me to answer just related to our software that we developed? Basically, two of the sources of whole life costs and whole life carbon are not easy to come by, and that's one of the big hurdles and barriers in our industry, is that designers don't have access to that information readily in a form that makes it easy for us to make the right design decisions. So that's exactly what our piece of software is aimed to do. So one of our partners was BLP, the insurance company. They have a very large database built up over many years of whole life cost and carbon across different window manufacturers, different boilers, different floor finishes, and we were able to access their database for the purposes of our KTP research project. We also use the RICS database for the less granular, more general information that we needed for the earlier RIBA work stages, more concept stages. And we had input from 2 other private sector organisations who need to remain nameless at the moment because of the arrangement we've got with them. But it wasn't easy getting access to the whole life cost and whole life carbon information. And obviously, the answers the software produces will only be as good as the data that it's got access to. So where you get the data from is going to be really, really important. And this is the rub, really, is manufacturers of underperforming products, underperforming materials that fail or that break down early, that cost a lot of money. They're not going to be very forthcoming with that, because what tends to happen is the industry brushes its problems under the carpet, as we all know. Mistakes are brushed under the carpet. There's very little learning passed down. People aren't keen to share negative information or negative performance about their products. So what we do think there needs to be some sort of shared common database where manufacturers are required to provide independently verified information about the performance of their products and materials, and they have to demonstrate that it's been independently verified. Otherwise, they'll get penalised for that, if you like, in the software. They won't get the best rating. So there's got to be an incentive for the best manufacturers will produce good data. They will get it independently verified, and then their products and materials, the information will be available for designers to access. And then the less good parts of the industry will fail to do it. And hopefully that's one way we can edge those sorts of organizations out of the supply chain and just attract the good ones.
Super. Thank you, James. Well, we're coming fast up, approaching our allotted time at 2 o'clock. I mean, there are a huge number of questions emerging from things I really don't understand, like cryptocurrency and tokenizing, which I'm sure probably Philip will understand, but I won't, to when's your software going to be available, James and Philip, so lots of really interesting comments, and also about the existing building stock and when we talk about embodied carbon. So I think probably many subjects and questions that we won't be able to cover today, but if I could close proceedings today by thanking our speakers and our panelists today. A really fascinating talk about perhaps the brave new world that we're entering, and I should also say probably this started for our speakers, at least some of them, over 20 years ago with Murray Grove, and that enterprising nature that architects have, and in particular in this instance, James and his team at Cartwright Pickard to bring forward the Murray Grove building, which was the first volumetric project, construction project in the UK, is commendable, and to think it needs that sort of enterprising nature, I think, to build a digital construction industry in Britain. One last thought I'll leave you with as our panelists, but also as our audience, is we heard from Philip some figures about carbon savings and the investment required perhaps for those carbon savings. And if you do your sums, it was about £200 a tonne, the investment for saving embodied carbon in that particular construction instance. It would be interesting, I think, for us as an industry to get more fluent with carbon and operational costs, and we always talk about spending more on the build to save money and carbon going forward. I think as an industry we've got to better understand that and be more conversant with those numbers. Anyway, thank you very much to our panelists, so to Alexandra, James, Philip and Gavin today from the CFCI. Very much appreciate your input today. Just one parish notice from the CFCI today, in that our next webinar is already, planning is underway. 2 or 3 weeks time, please keep a lookout for your emails. We'll be notifying you when that is. It's going to be a talk on a sustainability topic, and we'll let you know more near the time. Okay, It's 2 o'clock. It's time to finish your lunch and go and do your afternoon work. Thank you very much, everyone, and goodbye from us all at the CFCI. Thank you very much. Bye-bye.